Inside this truck is the most expensive material in the universe, costing approximately $62 trillion per gram. This is the first time it's ever been transported like this, and being able to move it around might help scientists unravel some of the biggest mysteries about the origins of the universe. Transporting this material is no simple task. If a single particle of the antimatter inside this truck makes contact with one of the protons surrounding it, they would annihilate one another, turning all of their mass into energy. That means kaboom. Matter-Antimatter annihilation has long been the stuff of science fiction, with antimatter engines powering the adventures of Star Trek's Starship Enterprise and antimatter-based weaponry featured in stories like Angels and Demons and the Halo franchise. Matter and antimatter react so explosively together because they're like exact opposites of one another. To briefly explain, I brought Anti-Jesse. Can we get some kind of barrier here so we don't annihilate each other? Thanks. On team regular matter, we've got positively charged protons and negatively charged electrons.
On team antimatter, we've got negatively charged antiprotons and positively charged anti-electrons, called positrons.
There's also neutrons and antineutrons.
Some people have said there may be entire antimatter planets and antimatter stars.
So what's different about you, Anti-Jesse?
I'm not sure. Do you have these freckles?
Stop, what are you doing? Ah! Are the fears of weaponizing this material valid or overblown? What is the purpose of shipping it like this? And what cosmic mysteries might be solved because of it? The answer to my questions lay with this man, Dr. Stefan Ulmer.
It is true that if you accumulate half a gram of antiprotons and you annihilate them at once, I mean, this has the destructive power of an atomic bomb. But to accumulate half a gram, given the current accelerator technology, you need to accumulate for 75 billion years.
When you're working with antimatter, a certain amount of annihilation comes with the territory. In fact, Ulmer told me he sees it all the time. Here's what it looks like to scientists when matter and antimatter meet. Ulmer's team at CERN is not measuring their antimatter in grams, which could cause a catastrophe if it annihilated all at once. They are measuring them in individual antiprotons. Nearly 100 of those antiprotons were in the truck that made the historic trip around CERN's facility.
In this antimatter transport, you know, like the most dangerous thing is still like the fuel in the tank of the truck.
The team does still have to take precautions to avoid losing these precious antiprotons in transit, so they put them in something called a penning trap, which suspends them in a vacuum and traps them with magnets. Ulmer told me it's the best vacuum that's ever been measured.
Antimatter not annihilating is a pressure gauge.
That's awesome. That's probably the most expensive pressure gauge ever.
It's also the most precise one.
The astronomical cost of antimatter comes from the large amount of resources required to make and capture very small quantities. CERN does this by smashing very fast protons traveling near the speed of light into a piece of iridium metal, creating antiprotons, among some other things. But the same thing that makes CERN the ultimate antimatter factory also is what makes it difficult to study antimatter on site.
The accelerator running creates very strong background magnetic field fluctuations. And these background magnetic field fluctuations talk to the particles in the penning traps, and this leads to these blurry pictures.
Scientists can't unravel the mysteries of the universe by looking at blurry pictures. That's why antimatter needs to be brought off-site, where it can be studied without interference to get a clearer picture of what's going on. This will hopefully lead to answers about why there seems to be so much more matter than antimatter in the universe, information which may help us better understand the origins of the universe itself.
Antimatter looks kind of similar to matter, right? It's the perfect mirror image. The mass of the antiproton is to 11 significant digits. The magnetic moment of the antiproton is to 9 significant digits. There must be some asymmetry somewhere. At least this is my reading. So maybe we find it in the next order of magnitude. This hunt for this new physics that makes you creative. And we are doing this to better understand basically the fundamental physics of the universe. We will never stop unless either we have found something or we have convinced ourselves that we have reached limits in measurement accuracy that we cannot overcome anymore.
Now this may sound like a lot of extra work just to get measurements of antiparticles that are a few orders of magnitude more precise, but Ulmer told me that it's in the hunt for greater precision that major discoveries may be waiting for us.
That's totally exciting, you know, that you can do this and that this is then immediately related basically to some very big fundamental questions. I mean, it's like heaven.
What's your version of heaven? Let us know down in the comments and subscribe for more stories that make you say, what the future?